Hello students, this is a sixth lecture on matrices. In this lecture we will be discussing invariance of rank under elementary operations. Under elementary operations or transformation. So firstly, in elementary classes we have studied what are elementary operations. Elementary operations elementary operation includes following three operation. Okay, first the interchange of any two parallel lines. Okay, interchange of any two parallel, like it could be interchange of two rows or it could be interchange of columns, right? Secondly, multiplication of all the elements of any line by any non-zero number is also elementary, also an elementary operation. Okay, multi okay multiplication of all the elements of any line. Okay, like if it is rj, it is multiplied by constant k. Okay, or this is c j and it is multiplied by, this is also multi this is also elementary. Third and last elementary operation is addition of addition. Okay, addition of any addition of the elements of any line to the corresponding elements of the other line. Okay, like this is this is added with some other row rk. Okay, or ri is added to scalar multiplication of some other row rk. Okay, and ci is operated in this way. Okay, this is also elementary operation. So these are the elementary operation which you have, I think, studied in elementary classes. Now I just want to tell you few results about invariance of rank under the elementary operation. Okay, I'm just stating the result without proof, because not very important to discuss proof here. Okay, first result is interchange of pair of rows, pair or any two rows, a pair of rows or columns does not alter the rank of the matrix. Not alter rank of a matrix. Okay, this is first result. I'm telling you this result without any proof. Okay, second is result 2, multiplication of elements, multiplication of of the elements of a row or column, of a row or column of a given matrix by non-zero number, okay, by non-zero number does not alter the rank of the matrix, does not alter the rank of that. Okay. Third result is addition to the elements of any row or column, addition to the elements of any row of any or column of the matrix. Okay, addition to the elements of any row or column the corresponding the corresponding corresponding elements of any row, corresponding elements of other row or column. Okay, column multiplied by any other, any multiplied by any non-zero. Okay, does not alter the rank of the, okay, does not alter the rank of the, you just said this, does not alter the rank. Okay, this operation, this third elementary operation. Okay, like if you are having three elements here, three elements. Okay, 1 1 2 3 4 5. Okay, if you multiply this by some constant k and add to this, okay, corresponding means 1 must be added to 4 into 2 must be added 5 into. This is the meaning of uh, third operation. Okay, so see here, first operation, first elementary operation was interchange of any pair of line, and second was multiplication of the elements of any line by a non-zero number, and third operation was addition to the elements of any line, the corresponding elements of other line multiplied by any number, right? This was the third operation. So you see, all the three operations are when all the three operations are applied on the matrix, it is not altering, it is not changing the rank of the matrix. Therefore we can conclude from these three result that, okay, you can write, therefore we conclude from these three result that elementary row transformation or elementary row or column operations do not alter the rank of, okay, do not alter the rank of the matrix, right? So this is about the invariance of the rank and the elementary. Now I would like to tell you about the equivalent matrix. Okay, what is equivalent matrix? And when an elementary operation is applied to a matrix, okay, when certain elementary operation, this is a matrix, and we have applied elementary operation on this matrix, we get a new matrix. Okay, so this matrix m dash, uh, you will be thinking it could be having different rank, but it's not so. Okay, order and rank is preserved in this, after this. Okay, as we told you right now that elementary operation do not rank of the matrix. This means uh, rank of m is equal to rank of, okay, and order is also same. Okay, or rank, sorry, elementary operation do not alter the order of the. Now the resultant matrix after we, which we got after resultant, this is the resultant matrix which we got after the, after applying the elementary operation, okay, is equivalent to given matrix. Okay, it's said to be equivalent to given matrix, and it is denoted by this sign. Okay, this m is equivalent to, okay, now we can find out rank by equivalent, this thing, right, equivalency thing. Okay, we are going to find out some matrix which is equivalent to the original matrix. Okay, first of all, let me give you an alternate definition of rank. Okay, rank is can be defined as rank of a matrix. If you see here, matrix, all the non-zero rows in this matrix, okay, how many non-zero rows in this matrix are present is equal to the rank of the given matrix. Okay, once again I'm going to tell you, rank can be defined as, rank can be defined as number of non-zero rows or columns, whichever is minimum, present in a, okay, for example, we are having a matrix 1 2 3 0 0 1 0 0 0. So here you see there are only two non-zero row, third row is 0, right? Okay, third row is 0 row, and we are having only two non-zero row. Okay, so therefore we can say rank of this A is equal to, right, and this matrix is also in echelon form. Later I'm going to tell you later this is what is echelon matrix. So now let us illustrate with some examples. We will be given a matrix and we are going to find out rank of that matrix using the reducing it to a equivalent matrix. Okay, so let us try. Well, okay, so see here, matrix is this, A is equal to 1 1 1, okay, 1 1 1 2 1 Okay, this is the matrix, and we are going to change this matrix into, okay, using the elementary operations. So what would be method, what would be our plan in this case? Okay, how we are going to change this matrix? Firstly, we are going to make this element using the, okay, then we are going to make this element 0 using the help, with the help of first element. Okay, this is the key element. Okay, this is our purpose. With the help of this element, we are going to make these two elements. Okay, if we are done with this, then we will be using this element, okay, to make it, okay, and if possible, it could be also made if possible, okay, using the help of, then we will be moving forward. Okay, then we will be trying to make it 0 if it is possible. If not, we will it as this, then this. So thus we will be, our aim is to make maximum rows or columns, 0 rows or columns, using the help of elementary operation, right? So that we can find out which uh, how many non-zero columns or rows are present in this. Okay, so firstly, see here, if I want to make this element 0, I would have to apply this operation on row, row 3, row 3 minus 2 time row, and similarly if I want to make this element 0, I will have to apply row 2 minus row 1. So whatever matrix I'm going to get here is 1 0. Okay, right? So see, this is 0 here. Now 1 minus 2, this minus 2 into 1, this is equal to minus 1 minus 2 into 1 is equal to minus. Okay, you see now, minus 1, second row, how row 2 is getting operated, it is row 2 minus, so minus 1 minus this, and 1 minus 1, it is first row. Okay, this matrix is equivalent to 1. Now what we are going to do, as I told you earlier, now we will try to make this element using the help of, with the help of uh, one thing we can do one thing, we can do one thing here, since we are trying to change this matrix into the equivalent form, so we can apply column operation and row operation simultaneously. Okay, so what we are going to do here, now we are going to change these two elements using the help of this key. So c2 minus and c3. See, if you want to make it 0, as I told you earlier, we would be going for this element. This is also right, no, but there is no problem with this, but okay, this will be pretty simple. Okay, because later on we will be discussing normal form, there it will, okay, because rank could be find it rank could be found out using this also, but later on it would be helping us in the normal form. That's why I with this process, right? So c3, first entry of c3 would become 0 when it is subtracted from, so what we are left with 1. Okay, 0 0 as it is. So now subtraction of 1 minus 1, 0, minus 2, minus 0, minus 1, minus 0, as 1 minus 1, 0, 0, 0, and we have made 4 entries, right? Nextly, what we are going to do now, our focus is on this element. Using this element, we are going to make it 0, and it is already 0. So if you want to make it 0, you will have to up it and subtract. Okay, so what I'm going to do, trying operation here, row 3 row 3 minus half of row, right? So it is equal to 1, 0, 0, second 0 as is. It is 0 minus 0, 1 minus half of is equal to minus 1, minus 1 plus 1 is, and 3 minus 0 into anything it is. So you see, we have reduced this matrix into the diagonal matrices, and here you see all the elements, all the rows and columns. Now further, no elements in this matrix could be made 0. As you see, all the elements which were about to become 0 elements, which we have made them 0, right? So now it is not possible to reduce it further, to make any other element 0 further. It is not possible. So this is the equivalent matrix to given matrix, right? And you also see here how many rows or columns are non-zero. All the 3 rows are non-zero. There is no 0 rows and 0 rows or 0 column in this matrix. Okay, all the rows or columns are containing certain non-zero elements. Therefore we can say it is definitely having rank 3, because we are having only 3 rows or 3 columns. Okay, 3 rows, all the 3 rows are non-zero. Therefore rank of the A is, right. So this is the way how to find out the rank of the matrix, using the by reducing it to an equivalent. Now let us discuss one more example, then we will. Okay, find rank of of the matrix x 1, 2, minus 1, minus 2, minus 4, 4, 4, minus 7, 1, 2, 1. So what is plan? Firstly, we are going to make these 2 elements 0 here. Then we are going to make the 3 elements 0 using this first element 1. Then we will be done. Now using this element we will be making this 0, then this, then we will be going further, right? So here matrix is A, matrix is equal to 1 minus 1, 4, 4, 1, 1, 2. Okay, if you want to make this element 0, we will have to apply operation on row 2, operation on row 2 plus 2 time you want to make this element 0, we will have to apply operation on row 3. Operation would be row 3 minus. In this way you will be getting an equivalent matrix 1 2 3. When you apply, you have multiplied this by 2, you're adding this to the corresponding row, okay, which will be 0, and you have multiplied this to 2 times 2 4 plus minus 4 0, and this would be again how much is 2 equal to, this would be 6 plus 7, right? 0 0 2. Yes, similarly this element would be 0 here because we are subtracting. This would be also 0, and you see 1 minus 1 is 2, and this would be minus. Okay, so see here 40 has been encountered. If you want to make these two elements 0, you can make it 0 directly. Now we would be doing what? We would be making these these three elements 0 using the help of first. Okay, now thought you can also do it directly because last row is become with the help of second, but I'm just going through the proper procedure or proper plan. Okay, we have already told you that firstly you first two elements 0, then columns entry 0, right? So now we are making columns, first column using the help of a11, right? Now c2 operating c time 1 3 minus plus add it to, and c4 4 minus 3, right? So what matrix we are going to get now is 1 0 0. Now 2 minus 2, it would be 0, 0 minus 0 0 minus, right? So 1 minus 1 plus minus 1 is 0 again, 0, 2 minus 0, 3 minus 0, right? 3 minus 3 is 0 again, because third operation is c4 minus 4 minus 3 times, it would be 3 minus 3, 1 minus 3 into 0 minus 1 minus again. So now this is 0, this is all the elements has become 0. Now we are going to use this element, make this. Okay, now if you want to make this element 0, we will have to apply operation on 3. So row 3 minus simply, okay, what we get, we are going to get 1 0 0 0 2 1 0 0 2 minus 2 0 1 minus 1 minus 0. Okay, so just see now with the help of this element this could be also made 0. Okay. Now you see how many 0 rows you are coming across, right? So this is non-zero row, right? This is 0 row, but third row is 0. So you are having number of rows which are non-zero are 2 on, therefore rank of the given matrix. And you also see how many columns are there which are non-zero. So this column is non-zero column, this column is column, this is 0 column, this. So in this way also you see rank of the matrix is because number of the non-zero columns are, okay. So this is how we find out the rank of the matrix using the elementary operation. So I hope you got it, you got clarity on that, clarity on, okay, right? So this is it for today. In next video we are going to discuss normal form. Thank you.